Hi everyone. Today we bring you to weekly insights on dynamic analysis, response spectrum method part 2. Capricorn Technologies, a Win Zero company and a partner of choice of AC industry. Capricorn Technology is one of the biggest platinum partners of Autodesk and Bentley, along with authorized training center. We have 300 plus dedicated team members with clientage of over 20,000 customers in AEC and associated industry. Myself, Dipali Arora, Solution Specialist in Capricorn Technologies, New Delhi, will present you with weekly insights. This is part 2 of Response Spectrum Analysis as per Indian Standard IS Code 1893-2016, Part 1. If you haven't watched the first part of the video, I would suggest you to watch it first before continuing to Part 2. I will also mention the Part 1 link in the description box below. In this video, we will learn how earthquake definition is defined, response spectrum definition, and also how STAAD will calculate the base shear by itself. In the last video or in the last session, we have already defined dead load and live loads. Now we will move to the main part of this procedure, now that is creating a load case of response spectrum analysis. In a similar way, I'll click on load case detail, click on the option and over here, if you can choose from here response spectrum, or you can just keep it blank, and in the title write RSA, that is response spectrum analysis load case. See, I've already created a response spectrum analysis. Close. Now click on response spectrum analysis, click on add. So before moving on to this part, before defining response spectrum command, we have to specify the values that has to be considered to calculate the value of WI, that is seismic weight of each floor. Here, see, seismic weight of each floor is its full dead load plus appropriate amount of imposed load. That is, that we have defined dead load and live load. Total sum of all the floors in each floor is defined as seismic weight. So we have to define seismic weight, or we have to calculate the seismic weight. Actually, STAAD will itself calculate the value of seismic weight automatically. How? Let's see. So what we have to do is we have to define self weight in each direction, that is x, y, and z direction with the positive value factor of 1. So I will define first in x direction with a positive factor value of 1. Click on add. See, self weight in x direction is added. Similarly, y direction, and similarly in z direction. Sorry, I've created. I'll just delete this one. Now I'll again click on this RSA. I'll click on add. Now we will define the floor weights. So what we have to do is, just the only difference is that in this we have to, in response spectrum analysis, we have to define the load in all three directions has to be the same. So now let's do the thing. I'll say in floor loads, I'll click on floor loads. I'll click on group because we have defined it in group, as you can see in that loads. So floor load, for the dead load, I have added 5.1. So I'll say 5.1 in global X direction, in global Y direction, and in global Z direction. We have to define in all three directions in response spectrum analysis, and the values has to be the same. Similarly, for F2 floor load, I have added 7. So 7 kilonewton per meter square in global X, in global Y, and in global Z. So we have defined the dead loads as floor weights. Now we have to define live loads as floor weights. So for F1, we have defined it as 2. So global X direction, 2 in global Y direction, 2 in global Z direction. So for F2, it is 0.375 in global X direction, in Y, and in Z direction. Close. So we have defined the loads. Now we will simply say assign to view for self weight, and similarly for y direction also, and for z direction. Now all these weight will be considered to calculate the value of Wi. Like I told you, that is joint weights, or you can call it weight of each floor. Okay, now we will add the response spectrum command. How we will add it? Click on this RSA, click on add, and from here, third last option, response spectra command is there. So in code, I will select 1893 part 1 2016, because we are defining this in, we have used the definition or the IS code for the assessment is 1893 part 1 2016, and I'll say combination method, I'll choose CQC. If you want to like ignore the modes with mass participation, you can click over here. If not, I'm just doing it like this. And in subsoil, we have selected the medium soil, and in X direction. So where will be the value come for this direction, X direction? For the first response case, we will apply in the load in the X direction. The next part is how to calculate the value that must be entered over here. This depends on seismic definitions we have provided. So if we go to definitions, I'll say seismic definitions, we have used zone as 0.24 and reduction factor as 5 and importance factor as 1.2. So what is X? See, we are calculating the design lateral force of VB. VB is the base shear, and VB is equals to AHW. What is AH? AH is seismic coefficient. That is what we have to enter over here. How we will define it? AH is equals to Z by 2 into SA by G by R by I. SA by G value will be calculated by software itself. We have to just define AH values. Z is zone, R is response reduction factor, I is importance factor. When we calculate Z, we'll keep the values over here, and we'll get the answer as 0.0288. How we have entered this? I've already told you Z is 0.24. 0.24 by 2. 2 is the response reduction factor multiplied by the importance factor, that is I, by 5. Okay, and in scale, I'll keep default scale as 1. Even if you do not define the default value, it will automatically take the default value as 1. Now I'll just simply click on add and close. See, we have defined the response spectrum command, the main command to keep the procedure in a correct way and to analyze it without any errors. So one thing we must keep in mind, that response spectrum command is defined only after defining the loads. Okay, so this was in the positive X direction. Now I'll create one more load case for the Z direction. What will I write over here is RSA Z. Sorry, Z. Add. So in this, I'll just simply add the response reduction command, because we have already defined the loads over here. So we have to just define the response spectrum command after the floor weights. So click on response spectra. Similar way, select the code, select CQC. Now we have to select Z direction. In subsoils, take it as medium soil, and similarly 0.0288. Sorry, 0.0288, and default value as 1 and close. So we have created response spectrum command for both X direction and for both Z direction. Now we will add the analysis command. I'll go to analysis and define commands, click on add, close. Okay, now we will run the structure. So click over here, run analysis, save. Now after successfully running the analysis, click on view output file. Let's see what warnings are coming. So here, I'll just click over here, model base section. See, this is SA by G value that I told you. Start with calculate automatically. Just we have to enter the Z by 2 into I by G value, and it will automatically give us a Z by G value. So this is the time period it's taking, and VB is the base share. So this is a warning we are getting for in the X direction. As you can see, these are the modes value. Stat calculates the modes in 6 different modes values are given, and 90% of the mass participation is required. So as of now, it is less. That is why it is giving us this warning. What it is saying is base share VB calculated using empirical formula for fundamental time period multiplying factor VB by VB according to close 7.73 IS1 is, this is a multiplying factor that it is given. It is providing us, what it is saying is key for like number of modes to be considered, like, right? The number of modes to be used in analysis for earthquake shaking along a considered direction should be such that the sum of total of model masses of these modes considered is at least 90% of the total masses, right? So the warning we are getting is, as of now, VB is, what VB it is providing is less in mass participation. So this means we have to multiply our X value with this multiplication factor. So we can write somewhere 1.79444. This value we are getting for X. This is a multiplying factor. Now we'll click on this mod base actions, and this is the value we are getting for Z direction. See in Z directions, and same the multiplying factor we are getting is for Z direction is 1.5962. So what we have to do is, I'll simply close this, go on loading, click on load case details, click on RSA, click on this spectrum command that we have added, and over here multiply this X value with the multiplying factor the stat is providing us. That is for X direction it was 1.7944. So I'll just open the calculator and I will multiply this 0.0288 by 1.79444. Okay, so this is the value we are getting, 0.0516. Okay, 0.0516, 0.0516, and modify it. Yes, close. Similarly for Z direction, click over here. For Z direction, multiplying factor was 0.0288. Multiplying factor was 1.5962, 0.045. So I'll write over here 0.045. Click on modify, close. Again, we will run the analysis. Analysis and design, run analysis, save. Again, click on view output file, done. And now let's see what is the change in our results. See, now it is 1. That is, it is accepting this multiplying factor and also the values that we have entered over here, and it is considering the 90% of the mass participation. Similarly, we'll check for the z direction. See, it is now 1. So this was all about response spectrum analysis. I hope you guys had an insightful session. We shall be presenting with linear static analysis, that is joint weight method, in our next insight. For more videos and updates, do subscribe our channel Capricorn Technologies Private Limited. Like and comment if you like the insight. We would be delighted to hear from you. Please reach out to us for any suggestion, query, or topic you would want to discuss. See you next week.